In this video, we'll continue to look at solutions to CSEC Advanced Past Paper questions. And we'll be looking at questions 4 and 5 from paper 2 of June 2022. All right, so let's begin by looking at question 4, part A. Now, question 4, part A says, given that f of x equals x times 5 minus x all squared, determine f double prime of x. So that basically means you're supposed to find the second derivative. Now, many students would be more inclined to treat this as a product, but of course, it gets a little bit more complicated if you actually apply the product rule. So what you could do instead is to expand the brackets. It doesn't take a lot of time, and that would probably help when it comes to finding the second derivative, right? So let's do that. So we can say that f of x is equal to x times 5 minus x squared. Now, if we square this, we're going to get 25 minus 10x plus x squared. Now, at this level, you should be able to expand a binomial like 5 minus x without actually going through the small steps. And so when we do that now, we're going to get that f of x is equal to 25x minus 10x squared plus x cubed. All right? So now that we've done that, we can say that f prime of x, the first derivative, is equal to 25 minus 20x plus 3x squared. So that's the first derivative. The second derivative, f double prime of x, is equal to, the 25 is a constant, it goes to 0. This becomes minus 20 plus 6x, which of course we can write as 6x minus 20. Now that is one way of approaching this question. But as I mentioned a few minutes ago, many students would have been inclined to use the product rule. And so for that reason, we're going to do this question again using the product rule, okay? So we're going to say let f of x be equal to x times 5 minus x all squared. And of course, we're going to let x be our u and this 5 minus x squared be v. So we can say that u is equal to x, which means that du by dx is equal to 1. V equals 5 minus x squared, which means that dv by dx is equal to, now this basically is a composite function. We're going to bring the 2 down, put it in front, multiply, write back the 5 minus x inside, reduce the power by 1, and then, because it is composite, we have to multiply by the derivative of what is inside the brackets. When we differentiate 5 minus x with respect to x, we get minus 1. And so this becomes minus 2 times 5 minus x, which of course is the same thing as minus 10 plus 2x, same thing as 2x minus 10. So having found du by dx and dv by dx, we can therefore say that f prime of x would be equal to u dv by dx plus v du by dx. And clearly, even so far, this is already taking up a lot more time, but of course we'll continue. So we get f prime of x is equal to x, which is u, times 2x minus 10 plus v, which is 5 minus x squared, times 1. And so this gives us 2x squared minus 10x plus 5 minus x squared. And that's only the first derivative. The question wants us to find the second derivative, and so we have to proceed to doing that, right? So let's do that, the second derivative. So we have f prime of x is equal to that. And so we're going to say now that f double prime of x is going to give us 4x minus 10, and then we have plus 2 brackets 5 minus x to the power of 1 times the derivative of 5 minus x, which is minus 1. And of course, you try to simplify. So this gives us 4x minus 10. Now this is 2 times 5 times minus 1, which is minus 10. and then we have 2 times minus x times minus 1, which gives us plus 2x. And so we have 4x plus 2x, which is 6x minus 20. So ultimately, we got the same result. However, by using the product rule, it took us a lot more time. And so I would recommend that if the power is not very large, you could actually expand the brackets instead of actually using the product rule, right? So that was part A of the question for 3 marks. Now let's move on to part B of this question. Now part B says, differentiate each of the following expressions with respect to x, simplifying your answer where possible, right? So we need to simplify our answer where possible, all right? So let's look at the first one. Now the first one we have, now for the sake, I'm just going to call this y equals 2 sine 3x plus cos x, right? So that's my expression. And I want to find dy by dx. So I want to find dy by dx. Now, the first part of our expression there is a composite function, and we have a multiplying constant 2, which we will keep. So this becomes 2, keep our 2. Now, when we differentiate sine, we typically get cosine, so we're going to have cos 3x, but because it is a composite function, it's not just sine of x, but sine of 3x, we have to multiply by the derivative of 3x. Now, when we differentiate 3x with respect to x, we get 3. So this becomes 2 cos 3x times 3, right? And then for the next part, we have plus. The derivative of cos x is actually minus sine x. And so we see that dy by dx is equal to 6 cos 3x minus sine x. And there's no further simplification we can do with that, so we'll leave it as it is. So for this expression, 2 sine 3x plus cos x, its derivative is 6 cos 3x minus sine x, right? So basically we can write that d by dx of 2 sine 3x plus cos x equals 6 cos 3x minus sine x. All right, next part now. Now, in part A of the question, we got an expression which resembles a product. And of course, we opted to differentiate it 2 ways, by first expanding the brackets and applying the just treat it as a polynomial. And of course, we also apply the product rule, and we show that basically when we use the product rule, it took us quite a bit more time than it would have taken doing it the previous method. But in this particular case, we're only required to find the first derivative, so we can basically go ahead and treat it as a product. So once again, we're going to say, for instance, let this entire thing be y equals 1 plus 2x cubed times x plus 2. And we're going to let the first part be our u and this part be our v. So we'll say that u equals 1 plus 2x cubed, which means that du by dx is equal to 3 times 1 plus 2x squared, reduce the power, and then now we have to multiply by the derivative of what is inside the brackets. When we differentiate 1 plus 2x, we get 2, and so this gives us 6 times 1 plus 2x squared. So that's just the du by dx. Continuing, we'll see that v is equal to x plus 2, which therefore means that dv by dx is equal to 1. And of course, by the product rule, we say that dy by dx is equal to u dv by dx plus v du by dx. And so dy by dx equals, so u equals 1 plus 2x cubed. So we have 1 plus 2x cubed times dv by dx, which of course is equal to 1, Then we have plus v, which is x plus 2 times du by dx, which of course is 6. Let me just remove this bracket first. So this is times 6 bracket 1 plus 2x squared. And this, of course, is one that can be simplified. So let's write this out as 1 plus 2x cubed plus 6 times x plus 2 times 1 plus 2x squared. Now, if we examine the two terms, we'll see that one has 1 plus 2x cubed, the other has 1 plus 2x squared. So we can therefore factor out 1 plus 2x squared in an attempt to simplify the expression. All right? So we can say that dy by dx equals 1 plus 2x squared. And when you say 1 plus 2x squared into 1 plus 2x cubed, this leaves us with 1 plus 2x. Then we have plus 6x times x plus 2. And we expand and we try to simplify the expression inside the square brackets. So we have 1 plus 2x squared. And this is now going to give us 1 plus 2x plus 6x squared plus 12x. And so this gives us 1 plus 2x squared times. Now 6x squared, 2x plus 12x, that gives us 14x plus 1. And that is the final version of the derivative of this particular product. Okay? So that's that part there. Now, part C of this question says determine the stationary points on the curve y equals x cubed minus 4x squared plus 4x. So first of all, let's write down the equation of the curve. Y equals x cubed minus 4x squared plus 4x. Now, when finding the stationary point on any particular curve, the first thing we have to do is to find the gradient function of the curve, that is dy by dx, or we could say f prime of x if given in x in function notation. So let's go ahead and find the gradient function dy by dx. And this is just a regular polynomial, so the usual rules of differentiation apply. So we say that dy by dx equals, we bring the power down, multiply by it, reduce it by 1, so we get 3x squared. Then we say minus 4 is a multiplying constant. We bring the 2 down, multiply by it, reduce the power by 1, and then this is just 4. Well, we could say 4 times x is 0, which ultimately will give us 1. And so this gives us 3x squared minus 8x plus 4. And so this is the gradient function dy by dx. So remember that whenever we're differentiating powers of a particular variable, we bring the power down, multiply by it, and reduce it by 1. And if we have a multiplying constant in front, we keep that constant, and of course it will be multiplied by any power that we actually bring down, right? So continuing. So dy by dx gradient function is equal to 3x squared minus 8x plus 4. Then we have to say that at the stationary point, so at the stationary point, dy by dx is equal to 0, all right? So the stationary point dy by dx equals 0. So what we will do is we'll set this equal to 0 and we'll solve for x. And so we have 3x squared minus 8x plus 4 is equal to 0. Now this is a quadratic of the form ax squared plus bx plus c equals 0. And we see that a equals 3, b is equal to minus 8, and c is equal to 4. Now let's try to see if it can be factorized. We say that ac is equal to 3 times 4, which is equal to 12. And we're going to ask ourselves, what factors of a positive 12 add to give negative 8? In other words, what two numbers that when multiplied to give a positive 12 add to give negative 8? And those two numbers are minus 6 and minus 2. So these two numbers are the two factors that we're looking for. And let's continue over here. And so we have 3x squared minus 8x plus 4 equals 0. And so we get 3x squared minus 6x minus 2x plus 4 is equal to 0. All right? Now the first two terms have as highest common factor 3x. So we can factor out 3x. We say 3x into 3x squared, that gives us x. Back or minus sign. 3x into 6x, that gives us 2. We close our bracket. For the next two terms, we must factor out a number so that we get the same thing inside the brackets. And this number is obviously negative 2. And so we get x minus 4, close our bracket, equals 0. And so we get by the distributive law, 3x minus 2 times x minus 2 equals 0. And we set each of these to 0 and we solve for x. So 3x minus 2 equals 0. 3x equals 2. And so x is equal to 2/3. X equals 2/3, right? 2/3. Or we can say that x minus 2 equals 0, which means x is equal to 2. All right? So I put this in brackets, not confusing one as a point, but these are just our factors. So yes, we've done that and we found the x coordinates of our stationary points. But let's go back at the question. The question specifically told us to determine the stationary points. Usually, when you see determine the stationary points, it means the x coordinate as well as the y coordinate, because a point has two coordinates, an x coordinate and a y coordinate. So what we must now do is we must write down the equation of the curve and we must find the corresponding y values at each value of x. So y is equal to x cubed minus 4x squared plus 4x. Right? So y equals x cubed minus 4x squared plus 4x. And therefore, we could say that y of 2 is equal to 2 cubed minus 4 times 2 squared plus 4 times 2. And what does this give us? 2 cubed, that is equal to 8. 2 squared, that's 4. 4 times 4, that is 16. Then we have 4 times 2, which is 8. So 8 minus 16 plus 8 actually gives us 0. And so therefore this point is 2, 0. So that is one of the stationary points right there. Right? Now to find this next point, we must substitute x equals 2/3. And so we must say that y is a 2/3 minus 2/3 rather. Y of minus 2/3 equals minus 2/3 cubed minus 4 times minus 2/3 squared plus 4 times minus 2/3. Right? Let's proceed. Now 2 cubed, that's 26, sorry, 2 cubed, that's 8, 3 cubed, that's 27. So this gives us minus 8 over 27. Then now we have minus 2 over 3 squared. That would be 4 over 9. We multiply that by 4, which gives us minus 16 over 9. And then we have 4 times minus 2 over 3. That is minus 8 over 3. Now for the purpose of adding without a calculator, I will write these as fractions, all of the same denominator, 27. So this is minus 8 over 27. Then multiply both numerator and denominator by 3. That gives us minus 48 over 27. This time we multiply by 9, numerator and denominator. So we get minus 72 over 27. And since our denominators are now all the same, we can just combine our numerators. So minus 8 minus 48, that's, well, let's go the other way first. Minus 48 minus 72, that's 80 plus 40, 120 minus 120 minus 8. That's minus 128 over 27. And therefore, the other stationary point is minus 2/3. Let's make a little bit of space here. So the other stationary point, of course, is minus 2/3 minus 128 over 27. So therefore, those are our stationary points. Well, but that was the end of part one. But now they want us to provide, well, providing details. Well, providing details. What kind of, anyways, determine the nature of each stationary point. I mean, details. Anyways, what we're going to do is we're going to find the second derivative and we're going to evaluate the second derivative at each of these stationary points, and that should be able to tell us whether it's going to be a maximum point or a minimum point. So first of all, what is our first derivative? What did that give us? Our first derivative, of course, is, where is it again? 3x squared minus 8x plus 4. So our first derivative is dy by dx, of course, equals 3x squared. So dy by dx equals 3x squared minus minus 8x plus 4. Minus 8x plus 4. Right. And so our second derivative, d2y by dx squared, equals, we say 2 3s are 6, 6x minus 8. And so what we must now do is to evaluate the second derivative at each of the stationary points. And so let's do the first one. The first one occurred, I think, was x equals 2. So at x equals 2, we can say that d2y by dx squared is equal to 6 times 2 minus 8. 6 2s are 12. 12 minus 8 is equal to 4, which is obviously greater than 0. And this tells us that this point is a minimum point, right? So because the second derivative is positive at that particular stationary point, it means that that point is a minimum point. And logic suggests that the second point, of course, will be a maximum. Let's just work it out here. So once again, let's just write down the expression for the second derivative. Let me see, where should I write it? Let's do it here. So d2y by dx squared is equal to 6x minus 8. And of course, at the point minus 2/3 minus 128 over 27, d2y by dx squared is equal to 6 times minus 2/3 minus 8. And that is obviously negative. So minus 2/3 times 6, this is minus 4, minus 8, which of course is equal to negative 12. And this therefore tells that this point right here is a maximum point, right? So that is the only details that we need to provide. We found the second derivative and we evaluated the second derivative at each of the stationary points, and we're able to determine whether the point was a maximum point or a minimum point. Okay, so that is the end of question 4 from the section, what's this again? Section 3. And of course, we'll be moving on to question 5. All right. All right, question 5. Question 5 says, determine the integral of 4 cos theta minus 6 sin theta. So just to jog your memory a little bit, just to jog your memory in terms of our derivatives, remember that d by dx of sine theta is equal to cos theta. And this therefore means that the integral of cos theta d theta is equal to sine theta, well, plus our integration constant c. Similarly, d by dx of cos theta is equal to minus sine theta, which therefore implies that the integral of sine theta d theta is equal to minus cos theta, right? And of course, we may be tempted to put our integration constant c. All right, so remember those derivatives there. So let's apply that to this question here. So therefore, the integral of 4 cos theta minus 6 sine theta. So minus 6 sine theta d theta equals. So the 4 and the 6 are just multiplying constants that we keep. So that is basically the same thing as 4 times the integral of cos theta d theta minus 6 times the integral of sine theta d theta, right? That is essentially what we're doing here. And so this gives us 4 sine theta minus 6 times minus cos theta plus our integration constant c. So you have to remember that when we integrate sine theta, we get minus cos theta, but we already have a negative 6. So we're going to multiply those now, and it will become positive. So therefore, this gives us 4 sine theta plus 6 cos theta plus our integration constant c, right? And we must remember that whenever we evaluate an indefinite integral, we introduce our integration constant c, all right? So that was part A of the question for 2 marks. Let's look at part B. Part B now wants us to evaluate the integral of 3 minus x all squared between the limits of 2 and 1. Now this, of course, is a definite integral, and because it is a definite integral, we do not need to be concerned about an integration constant, all right? So let's look at this. Now, we must also remember that integral of ax plus b to the n with respect to x is equal to ax plus b to the power of n plus 1 all over a times n plus 1 plus c, and of course we know that n is not equal to minus 1. So this integral right here is of that form, right? So let's proceed to doing this. So this becomes integral within the limits of 2 and 1 of 3 minus x squared dx. So essentially, this is of the form integral of ax plus b to the n, where a would be equal to, well, the coefficient of x. So basically a is equal to minus 1 and n is equal to 2. So with that in mind, we can say that this is equal to 3 minus x cubed divided by minus 1 times 3. So that is the integral of 3 minus x all squared. But of course, because it is a definite integral, we have to evaluate this between our limits 2 and 1. And so basically what this becomes is 3 minus x cubed over minus 3 to be evaluated between 2 and 1. All right? So what does this give us? Let's just keep the minus of anyways. If we substitute x equals 2, then basically this becomes 3 minus 2 cubed over minus 3, and then we subtract. When x equals 1, we have 3 minus 1 cubed over negative 3. So 1 cubed, that is just 1. So we have minus a third minus, right? So minus a third minus, and this becomes 3 minus 1, 2. 2 cubed is 8 over minus 3. So this is minus 8 over 3. These two negative signs multiply to become a plus, and so therefore what we get is minus a third plus 8 over 3, which of course is equal to 7 over 3. So our final answer there for this part is 7 over 3. All right? So assuming that we didn't make any little mathematical errors. All right? So let's move on to the next part of the question. Part C. Part C says determine the area of the region bounded by the curve y equals 5 plus 5x minus x squared, the x-axis, the y-axis, and the line x equals 2, right? Now, we don't know exactly what this curve looks like, but sometimes a little sketch of a curve will actually help us, right? So let's do a little sketch. All right. Now let's just say, well, it's going to be a quadratic, so it's probably going to look something like this. And we notice that the coefficient of x squared is negative, so it's going to be a something looking like so, right? Let's say it's going to have a piece over on this side. We know it's going to be go up and come down like that, something like that, right? Um, because of the shape. And let's say the x-axis, the y-axis, and the line x equals 2, right? So let's imagine that this is the line x equals 2, somewhere around, somewhere. Again, it's not a perfect sketch, but the line x equals 2, somewhere there. So essentially, we'll be integrating between x equals 2 and x equals 0, right? Mm-hmm. Because of course when the curve touches the y-axis or cuts the y-axis, at that point x is equal to 0. So essentially our limits become x equals 0 and x equals 2, and so we can say that the area is given by a equals the integral of 5 plus 5x minus x squared dx between the limits of 0 and 2. All right? So that is essentially what we're required to find. And so let's proceed to doing that, right? I'll just take this off here. And so we see that a equals, so when we integrate that, we're going to get 5x plus 5x squared over 2 minus x cubed over 3 to be evaluated between 2 and 0. Now, whenever we substitute 0, we must notice that each term inside the brackets includes x. So substituting 0 is just going to give us 0. So we just leave out that part. And so therefore, a equals 5 times 2 plus 5 times 2 squared divided by 2 minus 2 cubed over 3. And so a equals 10. 2 squared, that's 4. 4 5, that's 20. 20 divided by 2, that's 10 again. Then we have 2 cubed, this is 8. 8 divided by 3. If you want to leave it as a fraction, this is minus 8 over 3. So this gives us 20 minus 8 over 3. 20 is the same thing as 60 over 3. So this gives us 60 over 3 minus 8 over 3, which is basically 52 over 3. And because it's area, we just put squared units, right? So the area bounded by the curve y equals 5 plus 5x minus x squared, the x-axis, the y-axis, and the line x equals 2 is 52 over 3 squared units. So that was part C of the question. Now let's move on to part D, which involves kinematics, right? Now let's look at part D. Part D says, a particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration a is given by a equals 3t minus 1 meters per second squared. When t equals 2, the particle has a velocity v of 4 meters per second and a displacement of 6 meters from O. So we're given quite a bit of information there. Information pertaining to the velocity at a particular time and the displacement at a particular time as well. And they want us to determine the velocity when t is equal to 4. Now, we're talking about acceleration being a function of time. And so we say that we're given that a equals 3t minus 1. And this, of course, is measured in meters per second squared. Now, they want us to find acceleration, and we must remember that acceleration a is equal to dv by dt, which therefore means that the velocity v is equal to the integral of acceleration with respect to time. So we differentiate velocity to find acceleration, and to therefore find velocity from acceleration, we integrate, all right? So therefore, we can say that the velocity v is equal to the integral of 3t minus 1 dt, because of course that is the expression for the acceleration. And so this gives us 3t squared over 2 minus t plus our integration constant c, right? So let's continue over here. So we can say that our velocity v is given by 3t squared over 2 minus t plus c. And what information are we given that will allow us to find the value of our integration constant c? Let's go back to the question. We're told that when t equals 2, the particle has a velocity of 4 meters per second, right? So we say that v equals 4 meters per second when t equals 2 seconds. And this therefore will allow us to find the value of our integration constant c. Okay, let's do that. So we therefore now say that 4, and we could leave off the units, 4 is equal to 3 times 2 squared over 2 minus 2 plus c. So 4 is equal to, now 2 squared, that's 4. 4 3 is 12. 12 divided by 2, that's 6. So 4 equals 6 minus 2 plus c. 4 equals 4 plus c. And this obviously tells us that c is equal to 0. Now, having found the value of c, we can therefore say that the velocity equation, well, the equation now becomes v equals 3t squared over 2 minus t. So that is now our velocity as a function of time, because we found that our integration constant is actually equal to 0. But the last part of the question actually wants us to find the velocity at 4. So we can say that v of 4 is equal to 3 times 4 squared divided by 2 minus 4, which gives us 3. Now 4 squared, that is 16. So 3 times 16 over 2 minus 4. 16 times 3, that is 48. 48 divided by 2, that is 24. And 24 minus 4, then that gives us 20 meters per second. All right? And so therefore, the velocity of this particle is equal to 20 meters per second at 4 seconds. All right? So this is the end of question 5 and of course section 3 from May-June 2022, paper 2 of CSEC Admaths.